Hi everyone, welcome back. In this video, we're going to take a look at equivalent algebraic fractions. If we take a look at our first example, we can see that we have an algebraic fraction because we have a fraction where the numerator is an algebraic expression, and in this case, the denominator is an algebraic expression as well. Now our goal is to simplify this or reduce it to its lowest terms. In order to do this, we are going to follow a series of steps. It's going to be the same steps every single time. Our first step is going to be to factor absolutely everything. So in this case, I'm going to consider the numerator and the denominator to be separate, just to make it a little bit easier to see. So in our numerator, we have x squared minus 5x plus 6. Now this is a simple trinomial, so to factor it, we need to consider two numbers that multiply to 6 and add to negative 5. And two numbers that work in this case are negative 3 and negative 2, because negative 3 times negative 2 gives you a positive 6, and negative 3 plus negative 2 gives you a negative 5. So this expression in factored form will be x minus 3, x minus 2. If we look at our denominator, we have x squared minus 9. Now this is a difference of squares because we have a perfect square minus another perfect square, which means to factor this, we are changing it into x plus 3, x minus 3. After we factor it, let's put everything back into the fraction. So the numerator is x minus 3, x minus 2, and our denominator will be x plus 3, x minus 3. After everything is factored, we can go on to our second step, and our second step is reduce. So what that means is if we have the same bracket on the numerator as well as the denominator, we can cancel them out. So in this case, we have x minus 3 in the numerator as well as the denominator, so we can cancel that out. And that leaves us with a simplified fraction of x minus 2 divided by x plus 3. Let's look at another example. So in this example, we're going to follow the exact same series of steps. So we're going to start by factoring the numerator as well as the denominator. When we look at the numerator, what we have is 6x squared minus 11x plus 3. There are several ways to factor this. I'm going to use a shortcut method. So I'm going to consider two numbers that multiply to 6. I'm going to go with 3 and 2, and two numbers that multiply to 3, so 1 and 3. And when I cross these and multiply them, so 3 times 3 gives me 9, 2 times 1 gives me 2, I want to make these numbers add to negative 11. So I need this to be a negative 9 and a negative 2. And negative signs can only go on the right side of this. So we need a negative 1 and a negative 3 in order to make this happen, which means our factored form now, we're reading this from left to right. We have 3x minus 1 multiplied by 2x minus 3. On the denominator, we have 2x squared minus 3x. This can be factored by common factoring. They both have an x term. So if I take that out, I end up with 2x minus 3. Putting everything back into the fraction then, this turns into 3x minus 1 times 2x minus 3. And on the denominator, I have x times 2x minus 3. So now that we have factored everything, we can go to our second step, which is reduce. So to reduce this, we are crossing out brackets that are the same on both the numerator as well as the denominator. So we're going to cancel out the 2x minus 3's, which leaves us with a simplified fraction of 3x minus 1 divided by x. Let's take a look at another example. So in this example, we have x squared minus 9y squared divided by 3xy minus 9y squared. So same thing here, we're going to start by factoring absolutely everything. When we look at our numerator, which was x squared minus 9y squared, this is difference of squares. We have a perfect square minus another perfect square. So this will simplify to x plus 3y times x minus 3y. When we look at our denominator, we have 3xy minus 9y squared. This can be factored using common factoring. They both have a common 3. 3 and 9 are both divisible by 3, and they both have a common y. So I'm going to take out the 3 and the y, leaving me with x minus 3y. When I put the factors back into the fraction, my numerator is x plus 3y, x minus 3y, and my denominator is 3y times x minus 3y. Then I go to my second step, which is reduce. And when we reduce this, we are canceling out our common brackets, which is the x minus the 3y, and that will leave me with a reduced fraction of x plus 3y divided by 3y. And that is our final answer. Remember, we cannot cancel out the 3y's because the one on the top is not a factor. Let's take a look at one more example. So in our last example, this looks a little bit complicated. That's only because we have complex trinomials on both the top and the bottom, but we know how to deal with these. So let's factor your complex trinomials in the method that you like best. We have 5a squared plus 39ab minus 8b squared. And I'm going to factor this using the shortcut method. Think of two numbers that multiply to 5, so I'm going to use 5 and 1, and two numbers that multiply to 8, I'm going to use 1 and 8. When I cross these, 5 times 8 gives me 40, 1 times 1 gives me a 1. I need it to add to 39, so the 1 needs to be negative, meaning I'm making this negative. Reading this across left to right then, we have 5a minus b multiplied by a plus 8b. On our denominator, we have 5a squared plus 4ab minus b squared. So same thing here, multiples of 5, 5 and 1, multiples of 1, 1 and 1. We need this to add to a positive 4. 5 times 1 gives us 5. 1 times 1 gives us 1. Because we need it to add to a positive 4, the 1 needs to be negative. So reading this left to right, we end up with 5a minus b multiplied by a plus b. Putting everything back into our fraction, we get 5a minus b, a plus 8b, divided by 5a minus b, a plus b. Now we can go on to our second step, which is reduce. So we're going to cancel out the common factors. In this case, it's the 5a minus b. And that leaves us with a final answer of a plus 8b over a plus